looking at my x's and then looking at my y's, I see that x has opposites. 4x and negative 4x are opposites. When you're doing elimination, you want opposites. What we're going to do is we are going to add these two systems together. 4x plus negative 4x is 0. It eliminates the x value. 2y plus 3y is 5y. 9 plus 16 is 25. Y is 5. Once you find one variable, plug it back into the equation. Either one, it doesn't matter which one. Plug it back in to find your other variable. X is negative 1/4. And remember, for systems of equations, we can write these as an ordered pair. Negative 1/4, 5. In the got it question, do you see any opposites? Chen. Yes, exactly. So we are going to add these two equations together. Negative 2x plus 5x is 3x. 8y minus 8y, the y's are eliminated. Negative 8 plus 20 is 12. Divide both sides by 3. X equals 4. And then just go back to one of your original equations. It does not matter which one. And plug in 4 for x. What is 20 minus 20? 0. What is 0 divided by negative 8? 0. It's okay to have 0 as an answer. Every now and then when you get 0, you think, oh, that can't be right, it's 0. That's okay. 0 is just a number. It can be your answer. As an ordered pair, it would be 4, 0. So that's pretty simple, right? This way is a little faster than substitution. Right here, you don't have any opposites. If you look at the x's and if you look at the y's, you don't have opposites. So like Chen was asking, we couldn't do elimination right now because we don't have opposites. However, you can manipulate these equations to create opposites. It does not matter which you pick, x or y. Let's choose x just for this example. Looking at our x values, 2x and 3x, what is the least common multiple between 2 and 3? Sid? Right. So I'm going to change my first equation by multiplying it by 3. Now I have 6x plus 21y equals 12. You do not change the value of the equation as long as you're multiplying everything by the exact same number. That's one of our properties of equality. Now I want to create an opposite. So if I want the opposite of 6x what is the opposite of 6x, Jess? Right. So how could I change 3x plus 5y equals negative 5? What could I multiply that by, Liz?
Negative 2.
Very good. So now I have negative 6x minus 10y equals 10. Now you have opposites. Add the two equations together. The 6's are eliminated. 21y plus negative 10y is 11y. 12 plus 10 is 22. You get that y is 2. Now go back to an original equation and plug the y value in. And when you solve, you get that x is negative 5, giving you an answer of negative 5, 2. If you have opposites right away, you do not need to change the equation. But if you need to create opposites, then you just multiply by the least common, you just get them as the least common multiple, and you change each equation by multiplying. Sometimes you don't need to change both. Once in a while, you'll only need to change one equation. Example a little further on in our notes. Okay, they're saying that here in this previous problem, we found that y was 2. And then as you can see, what we did was we went back and we plugged 2 into our first equation. If we would plug 2 into the equation 3x plus 5y equals negative 5, would we get the same answer? Let's find out. X is negative 5. We do get the same answer. Why? Because there is one x value and there is one y value that make both of these equations true. There is one x value and one y value that make both of these equations true. So y is 2 is going to be the only y value that will make them both true. X is negative 5 is the only x value that will make them both true. Systems have one answer, except for special cases. Next one. What is the solution to this system? We have 3x and 5x. Those certainly are not opposites. We have 7y and 2y. Those are not opposites either. I don't care whether you make x or y opposites, and it doesn't matter. Which ones do you guys want to make opposites, x or y? X? Okay. So what is the least common multiple between 3 and 5? 15, right. I'm going to multiply my top equation by 5. 15x plus 35y equals 75. What should I multiply the other equation by? Sadie.
Negative 2.
Very good. Negative 15x minus 6y equals 12. Now we have opposites. Add the two equations together. 15x's cancel. 15x plus negative 15x, it's eliminated. 35y minus 6 is 29y. $75 plus 12 is 87y. And if you divide, what is y? Sadie?
3.
Right, y is 3. Once you get one variable, go back. Put it into the original equation. 3x plus 7y, substitute 3 in for y, equals 15. (3x equals negative 6). So x is negative 2. As an ordered pair, that is negative 2, 3 as your answer. That reasoning question, it's actually referring back to the question right before this. It says, in problem 4, you found that y was 2, and substitute this value into the second equation instead of the first one. Do you get the same value of x? Special cases, they're easy. Truly, for these, they're easy. So if you look at these two systems of equations, we have 3x plus y equals negative 5, 3x minus y equals 5. Let's use elimination since that's what we were working with today. Do you see opposites there? Yeah, there's all kinds of opposites there. Negative 3x and 3x are already opposites, so just add these two equations together. Negative 3x plus 3x, they eliminate. Y plus negative y, they eliminate. So if everything is eliminated on the left-hand side, we just end up with 0. Negative 5 plus 5, that's just 0. So we get a statement of 0 equals 0. Well, that's true, right? 0 does equal 0. Since this is a true statement, this is a special case that has infinite solutions. You could choose any x and y value to plug into those two equations to make a true statement. If you use substitution, you could work through that whole two sets of equations using substitution, and you would still end up with a true statement. And anytime you have a true statement, you have infinite solutions. That is called a consistent system of equations. That's just a special vocab word that refers to a system with infinite many solutions is called consistent. Now you can see in example B, we have opposites. 4x and negative 4x, they're opposites. Negative 6y and 6y, they're opposites. So on the left, both things are eliminated. We're left with 0 on the left-hand side. However, we're left with 6 plus 10 equals 16 on the right-hand side. 0 equals 16? I don't think so. So if you have a false statement, you have no solution. There are not two x and y values that you can use to make that true, no matter how hard you try. And this is called inconsistent. Looking at the got it question, we can make something an opposite pretty easily here, right? How could I make negative x the opposite of 2x? What would I multiply by? Josh? What? 2. Very good. So now I have negative 2x plus 2y equals negative 4. This is an example where I only had to change one of the equations. Now I can add these two together. The x's are eliminated. The y's are eliminated. 0 equals negative 4. Yu Chen? Right, so this is no solution. What should I multiply my first equation in B? What should I multiply that by? Jess?
3.
Not just 3. Very good. So now I have negative 12x minus 3y equals negative 18. Add your two systems.
Please pardon the interruption. Just a reminder for all students to vote in the Richland High School mock election. Students can vote by logging on at richlandsd.com and clicking on the election button at the top of the screen. Again, all students should consider voting in the Richland High School mock election. You can cast your ballots at richlandsd.com. Polls close at 8 p.m. tonight. Thank you.
Yu Chen.
For the two, I mean the one with no solution or